Restrict domains of functions to make them invertible. Okay, so we talked a lot in the last assignment about what makes a graph a function. So looking at this, that's the inverse right now. So the question my question, is this graph a function? So we can do the vertical line test. Okay, now these aren't perfect vertical lines, but assume that they are. This passes the vertical line test, okay? We have, where it gets really interesting is right here. I'm trying to make my actual line straight this time. And then we have one right here on the y-axis. We have one here right at 5, and another one at 10. So you see down here at -5, it's whole. It's colored in, which means at -5 our value is 0. But then if you go up here, it's open. What this means is that there is no value at -5 up here. Okay, so this does remain a function. If this were colored in, now it means that -5 goes to 0, and it goes to, 4.5. Okay, so this is a function. I just want to revisit that logic real fast before I moved on. Okay, now if we're asking, is the inverse of this function a function? So that means we have to pass the horizontal line test. And we can see that this is not a function. However, we could just focus on certain segments. So, is this only a function? Well, if we only care about what's in this is a function. This passes the vertical line test. And we can make another box to here. So we're going to restrict the domain, which is the x values, and we're saying, well, from 0 to -5, this is a function. And from -5 to -10, this is also a function. From 0 to +5, function. And from 5 to 10 is a function. And I should actually be a little clear. 0 to 5 is actually not a function, because, and 5, no, it's still a function. Sorry, I'm wrong. 0 to 5 function. Because once again, 5 does not go to, it only goes in one place. Actually, no, sorry. I misspoke again. 0 to 5 is technically not a function, okay? But 0 all the way up to 4.9999999 is a function. But once we get to 5, then it would fail our horizontal line test, okay? Look up here, we can see how 0 is equal on 0, but it goes up to everything less than 5, okay? So 0, including 0, up to 5, but not including 5, that is a function, as is C, from 5 up to less than 10. That's a function, and 5 to 0. Okay, so all three of these options would make our inverse function a function. Okay, if there's a line under these things, that would make it not a, all right? Or if there's a line only on one side and not this side, then once again it would be a function again. But because it's only saying this side's equal, but not this side, it remains a function. Next question. All right. So what can we do here to restrict? Waiting for, all right. So this does not pass the horizontal line test, but we could restrict it from, let's say, -1 to -2. That would be a function. We could go from 0 to -1. I don't see 0 to -1 or -1 to -2 up here. I do see -1 to 1. So let's see, -1 is here, and 1 is here. So in this box, let me erase this and start fresh. This looks all sloppy. Okay. So the first one says from -1, which is here, all the way up to 1. Now, in theory, this would actually go all the way down, but I can actually prove my point without going all the way down. So in this box, boom, fails the horizontal line test right there. So -1 to 1 is not a function because there's 2. -2 to 0. So -2 to 0, not a function, fails the test. 0 to 1, this would be a function. Everywhere you go from 0 to 1 only crosses the graph one time. So this is our answer, C. And there we go. Okay, where's the graph at? 0 to 4, negative 2 to 2, 0 to 2. I have a feeling the answer is going to be this one right here. But we'll see. Just by looking at the options, this is going over 4, also going over 4. This is only going over 2. So if you think all 3 of them, actually, no, we'll see. Where's that graph? There we are. All right, let's just go down one at a time. 0 to 4. So 0 is here, 4 is here. This includes both the 0 and the 4. You see the line underneath? So, if you look at 0, our value is 0. At 4, our value is 0. So the inverse is not a function, because 0 goes to both 4 and 0. So this would not be an answer. Negative 2 to 2. Well, here's our box. And this also includes both negative 2 and 2. That's very important to understand. So at negative 2, where do we go? We go up to 2. At positive 2, where do we go? We go up to 2 as well. So 2, the inverse function will go to 2 and negative 2. So the inverse of this is not a function. 0 to 2, that is a function. So C is our option. A and B are not. From 0 to 2, we only cross one time. Okay, and one more question. There we go. All right, so negative 3 to 1. So negative 3 to 1. Oh, I didn't go. I went to 0 first. Let's see. 0. And go over. Down to 1. Not letting me draw down here. It's out of the drawing region. Okay, that's why it's not letting me draw. There we go. Right at the very bottom of the drawing region. So, does this pass or fail the horizontal line test? Fail. So it's not that one. Negative 5 to 5. Well, if this smaller one failed, the bigger one's going to fail. So that's not the answer. 5 to 9. Okay, so I'm going to do a different color. It's getting a little, actually, let's erase everything. So 5 is here. And then 9 goes to here. So draw down here, but if this box went all the way down, this would also fail line test at from 5 to 9. So there's no answer here. At least no options. I mean, we could restrict certain portions of this graph to make it a possible invertible graph, but what they gave us, these options up here, none of the options are actually true. And there we are. We're done.